this whole thing's, never mind. Okay, so the horizontal stretch by a factor of what? See where I'm at? You can just answer. I'll take it.
The horizontal stretch of 9.
Of 9. So at the very least, even if we've lost all of our brain cells, we've narrowed it down, well, half our brain cells, we've narrowed it down to 2. Do you agree? And then it's a vertical stretch by a factor of?
4.
4. Yes.
4.
It is. Good one.
Yeah.
He doesn't want to not be first. Do you see this? It's competition now. That was pretty clear. That's some pretty clear. That's pretty nice. You guys can judge later and tell me. Okay. Milana transforms the graph of y equals f of x such that the equation of the new graph is this bad boy. Which quadrant does it lie in? So what do we always have to do first? Yes. I'll do that first.
At least for me, that's what I do.
I appreciate it. It's good. Okay. We make a C. So we want to get into y equals first, right? So we're going to have g of x, equals f, oh no, minus x plus 4 bracket minus 3. If you write too fast, it connects the things. Okay. Now, for Wednesday, we are going to make sure that every single time we have an equation, we have a what in front of our x? A 1. If we do not have a 1, we make sure we do have a 1, correct? If you do not have a 1 in front, you're immediately going to be wrong, just so you know. So it's the saddest thing. When I see someone doesn't move the equation so that there's a 1 in front of the x, I'm like, might as well not mark it because it's going to be wrong, because it has to be. Your horizontal translation will be wrong. Okay? So, unless sometimes people get those mixed up in like a double crappy way of doing it works out for them, but that's not normal. So always make sure that you have a 1 in front of your x or your horizontal translation will be wrong. So this one was nice. They already took the negative out, correct? So equation to words and mapping switches the x's, right? But words and mapping are in a heart. They're always the same. So what you do in words, you do in mapping. What you do in mapping, you do in words. So here we have xy becomes negative x minus 4, comma, y minus 3. Why is that? Because we have a reflection in the y-axis, horizontal translation 4 to the left, and the vertical translation 3 down. So this baby is going to flip along the y-axis, right? So it's going to go like this. And then it's going to move 4 left and 3 down. So let's try it out. So we have negative 2, negative 1. Oh, gosh. Is negative and negative 2, so 2 minus 4. And then negative 1 minus 3. So I get negative 2 and negative 4. So we're going to go here. And then people are like, wow, it's in quadrant 3, we're done. Would finding 1 point be good enough for you? No, I hope not, because you guys are overachievers like me. And we would want to make sure that the whole thing actually lands in quadrant 3, correct? To me, even doing 2 points wouldn't be enough to guarantee, because if I made an oopsie, yeah.
But if 1 point is in a quadrant and is asking which quadrant the graph lies in, if it would go in 2 quadrants, like if...
Then you made an oopsie.
Okay.
Right? So the reason why I would do more is because you might catch an error. So like if you do all 4 and they split between 3 and 4, you know you made something wrong. So maybe you forgot to take the negative out of in front of the x, or maybe you did something like that. So I always will do it all, because then if it all lands in quadrant 3, I feel good about myself, I'm smart, I move on, right? Now, we could say, hey, 1's there, it's probably all there. We can do that too, but then you won't catch an oopsie if you oopsie. So then this one is negative 1 and 1. Which is negative and negative 1, so 1 minus 4, comma, 1 minus 3. And I'm feeling confident because it's starting to get to look better. -3, -2. I'm not liking how these are connecting the stuff I'm doing. Now, the reason why I'm showing you this is because you don't plot all 4 dots and start connecting, correct? You plot a dot, you plot a new dot, hopefully you're plotting the one next to it, not some random one over here, and then massive chaos ensues. Do one dot, the next dot, and then connect, correct? Then go to your next one. I'm showing this because there are tons of times on the test that I'll give you something, and you guys will draw the graph, and you'll connect the dots wrong. And it's just so sad. Because you have the right dots, just not connected right. Now, here we have 1, 1. Becomes -1 -4. I have to write slowly or it connects the thing. 1 -3. So you get -5 and -2. I'm feeling super confident and I'm running out of room. And then 2, 2. At this point, I would probably say, hey, it's in quadrant 3 and feel good about myself. But I'm going to keep going. -2 -4, comma 2 -3. Oh gosh. -6 and -1. So you're in quadrant 3. Okay. Remember on your diploma, you have people in the room who don't know math. And if they did know math, they still couldn't answer you. So if you ask them which is the 4 quadrants, they can't answer you. First off, they probably can't actually answer you. Second off, they're not allowed to answer you. So you have to know all those things. So the range is what? X or Y's? Y's. The range of the graph of f of x is this. So it's 4 to infinity, and it's equal to 4 because it's a square bracket. It's a round bracket on infinity. It should always be. There's one question on the other quiz where it's a square bracket on infinity. That's an oopsie. It has to be a round bracket because you can't equal it. It's a concept. So the graph of y, so if this is more difficult for you to understand, then just rewrite it. So you're going to have y such that this is 4 or greater. So y is greater than or equal to 4. That just looks like a, there's no eraser, you have to. I think I might call it challenging. That's what I might call this board. Oh my gosh. It was sent to me to see how much I can take, you know, before I explode. I'm going to be okay. Oh. All right. So the graph is stretched vertically about the y-axis, or about the x-axis by a factor of 2. So vertical stretch by 2. That's helpful. I care about that. And then translate it 9 units down. I also care about that. What if they put on here horizontal stretch by a factor of smiley face, horizontally translated pig, and reflected in the y-axis? Would we care about any of that? No, because all of that would affect the domain, correct? So they could actually put variables on everything in the middle, and it throws people off. They freak out because they're like, there's a whole bunch of variables. It doesn't matter because what's with the x doesn't actually affect range, correct? So they were nice. They only gave you stuff that affected range. They should have thrown in here like a horizontal something. Like even a reflection in the y-axis would have made this harder, right? Because if it was a reflection in the y-axis, some people would apply it to this when it doesn't actually get applied to this. It would apply to your domain. So what's the only thing that causes this baby to flip, that inequality sign?
Dividing by a negative.
Dividing by a negative, so a reflection in the x-axis. Is there a reflection in the x-axis? No. Is there?
No, there isn't.
No. So it's going to stay the same, correct? Now they made this question easier. Remember, these are all released questions or past diploma questions to us. So they made this one easier because they didn't throw a reflection on here, right? If they threw a reflection, they could make it flop or they could keep it. So it would have made it harder again, right? So we're only, this inequality sign staying, which means this whole thing is staying. So I'm applying this all to the 4. So if I do mapping, my xy becomes x stays the same, and my y becomes 2y minus 9. So if I put my y in there, it's 2 times 4 minus 9, which is -1. Matches that. Oh, here's where some people start like being like, why? Why do you do the madness? Okay. I need buy-in. I need buy-in that when you see variables, they have to tell you what they can be. They have to restrict the domain of that variable, correct? So can you not just put numbers in there and then carry those numbers through, and now you have numbers and it's not nearly as overwhelming? Yes, you can do that. It takes me till about December till I get you guys to start putting numbers in for the variables, because you can, right? So for example, here it says the domain and the range of the graph of a function of y equals f of x are respectively. Respectively means in that order, correct? So the domain came first, then the range is second. And here they say p and q can't be the same. Okay, cool. And p can't be 0 and q can't be 0. So they can be whatever as long as they're not the same and they're not zeros. We agree? So I am going to make p be 2. And I'm going to make q be 3. Okay. So x is greater than or equal to, oh, I love how this thing writes. I do not. Y is less than or equal to 3. Okay. They're saying the domain is going to be x is greater than or equal to 2. X is less than or equal to 2. Y is greater than or equal to -3. Y is greater than or equal to 2. So now I have some numbers. Makes it maybe a little bit easier. Okay? So this affects my what? Range or my domain? Range, because it affects my y's. We agree? This affects my y. So is my domain changing at all? No. So my domain was this. My domain is still that. Is that a true or false statement?
True.
It's true. Okay. Now this one, my x is reflected. It's negative and reflected, right? So negative makes the 2 actually become negative. That's true. But it also does what to the inequality? It flips it. So they made it flip, but didn't do what? Yeah, it didn't make this sign negative, right? So they flipped the inequality, which was good. It used to be greater than or equal to. It's now less than or equal to, so that's perfect. But then I also need to apply the negative to the 2. So this one is actually incorrect. But we're going to go through and see why the rest are correct. Okay. So this one, I have a reflection in the x, and I don't care about it because it's asking me about range. So that's lovely. I don't care about it. All I care, I just hit something with my arm. I care that there is a negative here. So it's going to cause my range to flip and my number to become negative, correct? Or if it was negative, become positive. So it was less than. It should be greater than. Sweet. It was 3. It should now be -3. Is it? Yeah. So that's why this one's true. Okay. If I have inverse, that means x's and y's flip, y's and x's flip, correct? So the range of the inverse was actually the what? The domain of the original. We agree? What was the domain of the original? This. So now it's just going to be that, but with what values? With y's. So it's going to be y such that y is greater than or equal to p, or 2 in this case, yer, which it is. So it's true. Now, do you have to put numbers in? No. Just sometimes it's easier to visualize with a number rather than a variable. Does that make sense? So whenever they give you variables, they have to give you a restriction on what those variables can be. Now, you could have picked negatives for p and q, but why would you do that? Like, if you have the option, go the positive route, right? Because then a negative isn't going to be happening. All right. So statement 2. And then we're going to flip over. Oh no, screen. Okay, here we have The graph of y equals f of x is transformed. The new graph is y equals g of x. Both are shown. So this is the original. I'm going to do this. Okay. And it's turning into g. They give you mapping. Do you genuinely actually have to know anything if they give you mapping? You need to know nothing. If you know stuff, you could narrow it down faster. But you genuinely need to know nothing if they give you mapping. You need to know how to plug in a point for f into and then see if it gets you g, right? You could do trial and error, which would take you longer. So let's try and use knowledge. But if we had no knowledge, we could at least plug a point in and just hope it's not d, right? As the answer, because it'll just take you longer. So I know that this is facing, it looks like, to me, it looks like a seahorse facing the left. But it's now a smaller seahorse facing the right. So where did it reflect? In the y-axis. So I'm going to have a negative with the what? The x. If I reflect it, do I get a seahorse facing left? Yeah, so I have no other reflections. We agree? So I need a negative x. Well, that did nothing. That narrowed down nothing. Cool. Awesome. All right. Okay. It has shrunk vertically, correct? It's not bigger. So even if I don't even know how to calculate that, which one can I cut out? AB or CD?
CD.
And now what else can I cut out? B, because there's no reflection, right? So it's A. Well, that was kind of them. They gave the first one. Even if you did like trial and error, you were done after the first one. That's sweet. Okay. So here, we're given the equation y equals 1/2 x plus 3. Determine the equation of the function with a reflection in the x-axis. A reflection in the x-axis means my y it's negative going to affect all my y's, right? My y's are negated. Oh, yeah, my spelling looks terrible out here, but that's fine. Y equals negative. Now, remember when you do the negative, it has to apply to all the y's, correct? So we can even just do this. So we're going to get y equals negative 1/2 x minus 3. Now the great thing is when the equation doesn't have an f in it, there's no f in this one, correct? Could I not type the original in, type that into y2 and see if it's reflecting in the x-axis to check my work? Yeah. I could also look for my points. If it's a reflection in the x-axis, I should have, my points should be x, y originally for the y1, and then the y2, they should be becoming x stays the same and y is negated. Like you can check in your table of values, right? Because your table of values lists your y1 and your y2. Reflection in the x or the y-axis means x becomes negative x. So we're going to get y equals 1/2. X becomes negative x plus 3. Now this is right. It'll just never look like that. They'll put the negative in front, right? Because it's linear. Okay, this one we have to get y by itself first. So we get y equals f negative x minus 5. So when we say our transformations, do we have any stretches? Do we have any reflections? We have a reflection with the x, so it's actually a reflection in the y-axis. I don't think that's any better. Okay, and then we have a vertical translation. Five down. Now it didn't say mapping, but I'm going to prove mapping. So remember, if it's with the x, it affects the x. So this is with my x, so I'm going to get a negative x. Is this with my x? No, so it affects my y, so I'm going to get y minus 5. Mapping and words are the same, so if I have to move 5 down, I have to subtract 5. Okay, like I told you with b, I've told you this before, that if it's a negative x, more people will forget to take the negative out. If I put a 4 there, people would remember to take the 4 out more often than if I just have a negative in front. Okay? On the side, what if I gave you something like this? What if I gave you y equals negative 1/2 x plus 3? If I take that out, I take the negative 1/2 out. What am I left with? X minus 6. So remember, when you divide, take the 1/2 out, you're actually multiplying by negative 2. You divide by negative 1/2 and multiply by negative 2. Okay. So this one we have to take the negative 1 out. And like I said, I know the moment I put a negative 1 and not a number, people will forget to take it out. And you'll tell me it's 3 to the left when it's actually 3 to the right. So at the very top of your test, before you even start writing, I would remind myself, always make sure that there is a positive 1 in front of my x. And then on the next page, I would write, always make sure there's a positive 1 in front of my x. And then on the next page, you're getting the point. Always make sure there's a positive 1, because people you rush and then you forget, right? Or you just it's an easy mistake to miss. So, make sure you know. So if you don't have any stretches, we do have reflections, so we can actually put these together. We can say a reflection in the x and y axis. And then the horizontal or vertical, doesn't matter which one you start with. Horizontal translation. These boards were not made for math people. I just decided. 3 units, right? And a vertical translation. Units down. If I did mapping, I remember it has to go stretch, reflect, translate, right? Cert, SRT. So don't tomorrow just come in with them like all willy-nilly flipped. If you did stretch, reflect, then stretch, or stretch, reflect, you could kind of get away with it because they're both multiplication, correct? But the addition, subtraction, the translations have to apply. So here we would have, I didn't ask for mapping, so if you didn't have mapping, I'm expecting this not to be there. That's okay, I'm just reminding you of it. The negative x plus 3, because you're moving 3 to the right, comma, negative y minus 2. Here we have the key point, 110 is on the graph to determine the image point, so we have to use mapping. So we're going to subtract our 4 over. So we get xy becomes x plus 5, y minus 4, 110 becomes 1 plus 5 and minus 4, so 6 and 6. This one, we get xy becomes x minus 12, comma, negative y. 110 becomes 1 minus 12, comma, negative 10. So it's negative 11, negative 10. And then this one we have to remember to take the negative out. So we get y equals f, negative 1, x minus 3. So our y is going to stay the same, so we get xy becomes negative x plus 3 comma y, which is 110 becomes negative 1 plus 3 comma 10, which is 210. In this one, they want us to graph the following transformation as a function below, so we have to add the 1 over. So we get x, y becomes negative x, comma y plus 1. So I'd start with negative 6, 3. I don't even know what happened. So far, not happening. It comes 6, comma 4. Negative 4 and negative 3 becomes 4 and negative 2. 0, 0 becomes 0 and 1. And then 4 and negative 4 becomes negative 4 and negative 3. Now, some people would say that this is invariant because it stayed the same. Did it actually stay the same? If you use the definition of stayed the same, did this point stay the same? No, this point was this one. So they're very far apart, right? Stayed the same means I reflected it on the x-axis and it was on the x-axis and it stayed the same, right? Still exists is not invariant. Stays the same. Good thing those calculators are not like cell phones because I dropped them many times. Okay. Now, this daily quiz number 5, I threw big kahuna questions at you. I was like, hey, how can I throw some questions that make you do more thinking than just like a textbook question? Okay? So if you look at the transformed equation I gave you a vertical stretch, a horizontal stretch, a reflection in the y, a horizontal translation, and a vertical translation. If I start throwing all those at you, it's a standard of excellence question, just so you know. Like, that's a hard question. So, also keep in mind the domain and the range, okay? The domain here is from negative infinity to 5. People are usually better with that than if I give you like between 2 and 6. Because guess what people will do if I give you this? They're going to think this isn't a domain. They're going to think it's a coordinate, correct? And they'll plug it right into mapping. They'll plug this in for x and that in for y. And what should they actually be doing? If this is domain, this just means it's not equal to. They should plug this in for x and this in for x, because they're both domains, right? And what's the only thing that will flip these numbers? Yeah, a reflection in the y-axis. And I really hope you catch it. Because if you don't catch it, say you get your negatives, you're going to get like negative 2, comma negative 6. I hope you realize that that order makes no sense in domain. And you just be like, oh, dang it, there's a reflection. Oh, yeah, that's negative 6 and negative 2. Because when you give domain, these have to be in order anyways, correct? So I'm hoping that even if you get the plug the 2 and you get negative 2, plug the 6 and you get negative 6, you'll be like, wait, negative 6 has to come first in domain. So I can't write it like that, and you catch your mistake anyways. This has nothing to do with this question. I'm just stating that this question is easier because I gave you an infinity and it blatantly doesn't look like a coordinate. It even has square brackets. If I give 2 round brackets, oh boy, it looks like a coordinate. It gets put into mapping like a coordinate. We get coordinate answers, and they'll have the coordinate answer there. It's just that. So hopefully we don't get any of those. But I want to prep you for the fact that they could give you something like that and to be prepared for it. All right. So, given the original function is f of x, it has a domain of this, negative infinity to 5, and a range of 6 to infinity, Determine the domain and range of this transformed function. Not only did I make this ugly, I made your vertical translation be a fraction, right? So this one is quite difficult because you have to remember to take out the stuff in front of the x. You have to remember to divide the 3 over by both terms. If they give you something like this is the hardest they could give you. So if you can do this, you're totally fine. Okay? If you couldn't until today, that's totally fine as well. You haven't wrote a test. So there's a 1 sitting in front of here, correct? So the first thing I would have to do, some people will divide by 3 on both sides. I never do that because you can't reduce fractions if you do this. If you go 3 and you go 3, that's not helpful. I never will ever divide a whole side by 3. I'll divide every term by 3 because if not, you can't reduce a fraction. Even in grade 10, you should have never been dividing your linears the whole way across either. You should be doing every term. So, I divide this by 3. This term is one term. So I divide this by 3. I divide this by 3. Because that is a vertical stretch by a third, and it has to be done to all the terms. So now I'm going to have y equals 1/3 f something minus 4/3. Now I need to get to that something in the middle. What do I have to remember to do? Take out the negative a half. And when I divide by negative a half, I'm actually multiplying by negative 2. So it's going to be x plus negative 2 divided by negative a half is the same as negative 2 times negative 2 over 1, which is just 4. And remember, if you distribute that negative a half back in to check it, you should get what you had before, right? So if I put the negative a half in, I get negative a half x, good. And I get negative a half x, and then I get negative a half times 4, which is negative 2. So I know I did it right. You can check your GCF. Okay, when I go to do mapping, I have x, y becomes my x always flips except for my reflection. So negative a half is going to become negative 2x. And then my, plus 4 is actually 4 to the left, so I'm going to subtract 4. And then my y is 1/3 y minus 4/3. Now remember, you have the test on Wednesday. If you're still going, do I flip it, do I not flip it, do I keep it, do I flip it, do I not flip it, is it flipping it, I don't know. If you're doing that and you're coming into the test, that is a scary place to be. You need to know, when I take it out of the equation and I put it into words and mapping, I flip. Right? Words and mapping are the exact same. Equation to words and mapping, flip. Words and mapping to equation, flip. Right? You need to know when they flip and when they don't and not be iffy on it. If you're iffy on it, that makes for a scary test because all of the oopsie answers are there. Right? So if you're someone who forgets to flip, or you flip when you shouldn't, that answer will be there. So you need to know your stuff backwards and forwards. Does that make sense to you? The people who know them kind of like 75% scare me, because those sometimes result in some really bad marks, because you're flipping sometimes and you're not sometimes, and you're not sure when you're supposed to, and the answers will be there for every oopsie. Right? Okay. So this affects my domain. Look here, I have a reflection. So what does that mean when it comes to a domain? The inequality sign does what? It flips. So I know that my original domain is negative infinity to 5, sorry. It's now going to be something to infinity. Because this was y is less than or equal to 5, and I need it to be y is greater than or equal to something. Correct? Does that make sense? And then how do I get my number? Well, if my mapping is right, my number is really easy to get. Because I'm going to go negative 2 times 5 minus 4, which is negative 14. Okay? Then my range is 6 to infinity. Does it have a negative in front? Is there a negative here? No, so I know I'm going to get something to infinity. The inequality sign doesn't switch. Well, how do I get that something? I plug it into there. So I go 1/3 times 6 minus 4/3. 6 times 1/3 is 2. 2 minus 4/3. So that's 6/3 minus 4/3, which is 2/3. This question, I was just trying to drive home, what does an inverse do if you have an original, and do you actually have to find the inverse always, right? Tomorrow we're going to go over one question where I give you an equation and I make you restrict the domain of the original to make the inverse be a function. We're going to go over one of those two. So if the coordinate is negative 5, 2 on the original, it's going to be 2 and negative 5 on the inverse. The x just becomes the y and the y becomes the x. No negations change or anything like that. The domain of the original becomes the what of the inverse? The range, because the x's become y's. Okay, we have a y-intercept at 3, so that's 0, 3. So what does that become on the inverse? Yeah, because it becomes 3, 0, right? And then the equation. I put this on here because people often mess it up. Remember, you have to swap your x's and y's, so we're going to get x equals y plus 6 over 3. And technically that's right, but they're going to want it into y equals 99% of the time. I have seen it on a diploma where people get the question wrong because they just swapped the x's and y's and made it multiple choice, and then people kept trying to solve for y, and they're like, it doesn't match any. And I'm like, they just only swapped the x's. They made it too easy. That's what they did. So I have to bring the 3 up. So I get 3x equals y plus 6, and then minus 6. And some people might say, well, this is linear, and the other one wasn't linear. What the heck? The other one was linear. They divided the whole side by 3, which makes it not blatantly obviously linear. Remember I told you I don't ever do that. I don't ever divide a whole side by that. I'll divide each term by it. So this is actually the same as x over 3 plus 6 over 3, which is x over 3, or 1/3 x, plus 2. It is a linear. That becomes a linear, right? So it is actually the same. Now, instead of writing y, I'm going to write f negative 1x equals 3x minus 6. I can't remember. Is that last page? It should be, right? Is there another? There's one more. Okay. Ooh, my restriction. Now, this one here, we have given the graph of x squared minus 6, and I told you it doesn't have to be a quadratic. It could be an absolute value. It could be that they give you a graph that is a function. They could give you something like this and ask you how you would restrict the domain so that the inverse was a function, right? Well, what would you have to do? You'd have to just steal an arm off of these, right? So if this was like negative 2 and 2, if I restricted the domain between negative 2 and 2, it would now pass the horizontal line test, wouldn't it? So then the original would be a function. So if you just run a quick horizontal line through the domain that you restrict, and it passes, then that's a good domain to restrict. Okay? It's a really ugly question to mark because there's so many options. Like someone could pick between negative 2 and 3 technically and stop it here, and that would work as well, right? So there's so many options. So those are kind of ugly to mark, but they give you more options to pick. Honestly, the more options I give you to pick, I find the question is harder for you. Like if I only allow like one little piece to happen, you're like, got this. And then when I give you options, you're like, too many options, restrict me to something less. Okay? So it doesn't have to be a quadratic or an absolute. It could be just a function that they draw. Okay? All right. So if I look at this one, I picked this one specifically. Oh, this is going to be fun. Let's see how straight these lines are. Not too bad. Okay, I picked this one specifically because it is centered on the y-axis. And I told you when I centered on the y-axis, people do bad things. So I gave you one Practice. 1, 2, 3, 4, 5, 6. It's here, 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 and just something like this. I would need more coordinates. I'm just being lazy. All right. So how would I restrict the domain so this would be a function? Where is this graph cutting in half? On the y-axis. And what is x on the y? Because I'm asking for domain here. X equals what on the y-axis?
0.
So the y-axis is just the equation x equals 0, and the x-axis is the equation y equals 0. We agree? So there are numerous choices you could make here. You could say x such that x is less than or equal to 0, xer. You could say any variation of that, x such that x is less than or equal to -2. Because if you picked -2, that would be here in this way, and that would still pass horizontal line tests, wouldn't it? Because that's all I have. You could say, that's not a variance bracket. X is greater than or equal to 0. Or any variant of that, so you could go like 2 to infinity. Now, just so you know, this is set notation. Just a reminder. This is interval notation. If they ask for set and you give them interval, no marks. If they ask for interval and you give them set, no marks. Interval notation is easy to remember because it's just between two intervals. Set notation, when you squiggle this, you should say the set of x values such that x is less than or equal to 0, and of those values, x has to be none of the reals, right? So it's the set of. That's what the squiggly brackets mean. So that's why it's set notation. It's the set of. Okay? All right. I am going to hand out polynomial. So at the factor theorem. So the factor theorem is similar to the remainder theorem. What we really need to know is if something is a factor, the remainder is 0. So if this is a factor, and we know that the remainder is 0. Because it means that it goes into it evenly. So when you do long division, like when you're in younger years, and you don't get a remainder, then that number went in evenly. Like if you put 2 into 222, you'd get 1, 1, 1, and no remainder, right? So it went in evenly. So if something is a factor, same thing. If you actually did long division, you'd get no remainder, okay? Because it would go in evenly, okay? So we're going to verify this is a factor, and how you can do that is we're going to go back to remainder theorem on Thursday. But what we can do is we can use this and we can plug it in and see if we get a remainder. It's something we're going to learn later. So what we can do is we have x plus 2. We can solve that out just like we did in grade 11. X plus 2 equals 0. So x equals -2. And then we can do function notation, plugging that in for x and see if we get an answer of 0. Because if we plug this value in for x, we actually get the remainder. So if you're ever asked for just the remainder, this is the fastest way you can do it. You don't have, you can bypass all of the finding out the other stuff by division. If you just want a remainder, you can take this and you can plug it in for x and see if you get 0. So we go -2 cubed plus 5 times -2 squared plus 2 times -2 minus 8. So we're going to get -8 plus 20 minus 4 minus 8, which is actually 0. So we have f of -2 equals 0. So we know the remainder is 0. We also just found a coordinate, didn't we? Yeah. We put in an x, we got a y, correct? We've done that our whole lives, except we did it in t-tables. We had an x and a y t-table. All we did was we found a coordinate. This is my x, this is my y. So what coordinate did I come out with?
-0.
So all of your x-intercepts work backwards or factors? So say you had like an x-intercept of -3, 0. That would mean x equaled -3. What would that be as a factor? Move the 3 over. X plus 3 equals 0. So this would be your factor. And this would be your x-intercept. That's an equal sign, not an inequality. I don't know, my pen is not working. So we can actually do this without using remainder theorem. We can do this via actually synthetic division as well. But we're going to do another example where we're going to show it using remainder theorem, see what if it's a factor, and then we're going to do synthetic division. So here we have, for example, x minus 2 is x minus 2 a factor of x cubed minus 6x squared plus 3x plus 10? Well, we know we have f of x equals x cubed minus 6x squared plus 3x plus 10. And we're checking x minus 2. So what does x actually equal? X minus 2 equals 0, so what does x equal? 2. So we're going to look for f of 2. And f of 2 has to equal what in order for it to be a factor? What does f of 2 have to equal in order for it to be a factor? 0. So let's see it up. So we're going to go 2 cubed minus 6 times 2 squared. It just moved. Squared plus 3 times 2 plus 10 equals 8 minus 24 plus 6 plus 10. Why is it moving? It's just taking things and shifting them. So 8 plus 6 is 14 plus 10 is 24. 24 minus 24 is 0. So we can say we have a coordinate at 2, 0. And then we can say x minus, this is the remainder, sorry. It's just taken all my pretty writing and made it terrible. X minus 2 is factor. So below it, we're going to try synthetic division. Okay?
So even if it doesn't come out as 0, whatever value is there, it's still able to be put into a coordinate.
It's still a coordinate, just not a factor, because it wouldn't be an x-intercept. X-intercepts become factors, factors become x-intercepts, because in grade 11 you were taught, okay, if I was given, why is it just moving? X squared plus 3x minus 4, say this is grade 11, right? You were taught to set it equal to 0 and factor it. Grade 10 you were taught to factor, grade 11 you were taught to set this equal to 0 and factor. This is totally an aside, it has nothing to do with this question. So if I had x plus 4, and it's punking me, x plus 4 and x minus 1, these would be the factors, correct? Then what did I do? I took them, set them equal to 0 in grade 11 and solved, right? So I went x, maybe it's because I'm using the back, I don't know. X plus 4 equals 0, x minus 1 equals 0. So x equals -4, x equals 1. I think this pen does something different if you use the back. I think that's what it's, I think maybe it moves with it. I'm going to have to read the manual. I didn't know it was so fancy. So here you'd have x minus and 1, 0. Right? So you did this in grade 11. We're just doing it with larger things, like cubes.
What if it only has 1 or has no x-intercepts?
So when you go to look, it will have no x-intercepts. So it would have to be a degree 2 or a degree 4 or a degree 6. It would have to be an even function in order to have no x-intercepts, because it would have to be completely above the x-axis or completely below. Whereas like linears will draw, and their arrows go in opposite directions, they disco, so they're going to have to cross through at some point. Cubics as well. Cubics make like a sideways S shape. So they could have, at minimum, they're going to have at least one, because they're going to have to cross through somewhere, and then they can bounce up here completely above the x-axis, that's fine. But they're going to have to cross because their arrows are in opposite directions. So odd functions will have at least one x-intercept. Evens could have none. Yeah. All right. So we're going to try this through synthetic division. Do we have time? Yes, we do. Okay. So how we do synthetic division here is, I'm just going to rewrite this. So I have x cubed minus 6, x squared plus 3x plus 10, and it's being divided by x minus 2. Okay? So, how we set up our synthetic division sign. We're going to set it up and it's going to look like an L. Okay, like this. If I went like this, boom, boom, and it's an L. Okay? Pretending that this paper is nothing on. More like this. Okay? You have to get a row of numbers here and a row of numbers here. So don't draw like a shallow L. You have to draw like a longer L. So I'm drawing a longer L for a reason. So this would... I don't know why it's just... I think it's time to quit. Why is it? I feel like someone put a faulty board up, and they're just, what the heck? I just about swore.
It's bar all over again.
Do you remember the name of the plane?
Which one?
Just something like that.
Sure. All right. So we have to take the actual x answer. So we know we said x minus 2 equals 0, and we have x equals 2. So x equals 2 has to go here. So it's the same number that you would put in to find the remainder using function notation. It's the same number you put in front of your synthetic division. So we have to make sure we can count down, rocket counting, our exponents. So here we have 3, 2, 1, and this would technically be x to the 0, and we blast it off. We can rocket count. If we can rocket count, we can put the coefficients on the very top of our synthetic division. So the number in front of here is a 1, so I put a 1. The number in front of here, I think, is a minus 6, but I don't even know anymore because I've drawn so many lines over it. Is it a minus 6?
Yes.
This is a 3. This is a 10. That is legitimately the hardest part of this. Making sure you can count down. If you can't count down, say you were missing an x squared, you would just put a 0x squared there, and so you'd have a 0 in your synthetic division. You'd have a placeholder of 0. That's all that would happen. Okay, ready? We're going to drop a number, and then we're going to multiply and add until we're done. Okay? So we're going to drop the 1. So I put an arrow, and I drop the 1. Now, all we're going to do from here is multiply, then add. Multiply, then add. Multiply, then add. Okay? So we go 2 times 1 is 2. It comes up here. We're done multiplying, so what are we going to do? Add. What's negative 6 plus 2? Negative 4. We're done adding, so we're going to multiply. What's 2 times negative 4? Negative 8. Then we're going to add. 3 plus negative 8. We're done adding, so we're going to multiply. We're going to keep doing the exact same thing over and over and over. 2 times negative 5 is? And then we're done multiplying, so we're going to, and we're going to get, and we're going to box this, because this is our remainder. Now, we just took an x out of this whole x cubed, correct? If we take a GCF of an x out of all of these, they're all going to go down one exponent. We agree? So what we're actually left with here is 1. It was x cubed, so this is going to be 1 x squared minus 4 x minus 5. And what's fun about this is if you took this and you took your factor, is this your factor? No, that's your root. What was your factor? X minus 2. So I always write these up here to help me because then I have both. If you take these, the x minus 2, and you took this and you FOILed it back out, you would get the polynomial. You could add the remainder to it if you really want to, but it's 0. Right? So if you FOILed these back, you would get that. If I can actually factor this, I would go further, which I can do. I can factor that, so I would get x minus 2. That stays. And this would factor 2. X minus 5. X plus 1. And that would actually be the factored form. Tomorrow we're going to start with a little bit of review of pros and cons, a couple pros and cons questions. Make sure, oh, I have to hand this out. Make sure you